1492, Columbus sailed the ocean blue. Well, how did he navigate those waters? In this class, we discussed latitude and longitude, which he definitely used, but today we're going to discuss something else, the wind patterns, which Columbus used to navigate these oceans. But first, let's do a quick reminder. Wind is a change in air pressure. Colder air is going to be heavier and going to fall towards the earth. This is going to create higher pressure on the earth. Warm air is lighter and going to rise up, which means that there's not as much air pushing on the earth. This is called lower pressure. The earth is also turning, which means that winds that form are never going to go straight, but are going to curve. As Ms. B would say, winds in the south go to the left, and winds in the north go to the right. Areas also heat differently. Land is going to heat and cool faster than water, as well as the sun's rays are going to hit tropical areas near the equator more than at polar areas. So like temperature, wind is also going to change based on latitude, based on how high or low you are on the map. Ooh, that sound means it's time for a question. Check the form. If the Earth did not rotate, there would be just one circulation cell in each half. This means that warm air from the equator would rise and go to the North and South Pole, and then cold air would move down to the equator, where it would heat, and then rise and continue the cycle. But because the Earth rotates, the Coriolis effect prevents air from flowing straight from the equator to the poles. Instead, air flowing north from the equator is going to be deflected to the right. Air flowing south from the equator is going to deflect to the left. So this gives us the three-cell model. In the three-cell model, each half of Earth, the top and the bottom half, the north and the southern hemispheres, are going to have 3 cells of circulation, meaning the air is going to turn in 3 separate circles. The first one is between the equator, which is 0 latitude, and 30 degrees. The second is between 30 degrees and 60 degrees. And the third one is between 60 and the North Pole, which is 90. This is caused by changes from high to low pressure, and these winds are going to occur in belts, in these lines across the globe. In the North Pole, the cold air is going to fall. By the time it reaches 60 degrees latitude, it's going to meet this warm air that is heating up over here. It's then going to be pushed up back towards the North Pole. Warm air rising from the equator will get cold and start to sink by the time it reaches 30 degrees north. Because of this high pressure, it's now going to go back towards the equator. So let's talk about wind direction, which is caused by the Coriolis effect. Air going southward from the North Pole will turn to its right, creating wind that blows from east to west, as you can see in the highlighted sections. These winds are called easterlies. Between 30 and 60 degrees, winds that are going northward will be shifted to the right as well, and will be going from west to east, which are called westerlies. You can see that in the highlighted section. The reverse of this is going to happen in the south. Winds between 30 and 60 degrees that are going southwards are going to go from west to east, are going to go to the left, as opposed to winds that are going northward in the southern hemisphere are going to go to the left and go from east to west. Because of this model, certain areas of the Earth are going to have winds that are blowing in the same direction. This is called prevailing winds. The first example is the ITKZ, or the Intertropical Convergence Zone, which is where the surface winds from the 2 hemispheres, the top half of the Earth and the bottom half, the north and the south, are going to meet. This area of low pressure is near the equator and with a tropical climate, which means it's going to be hot, humid, little amounts of wind, and a lot of rain. Another example of common wind direction is going to be at the 30-degree latitudes, both in the north and the south. This is where the air is going to be sinking and going back towards the equator, and because of this, air is not going to be rising and causing rain, which results in deserts. So now back to Columbus. Columbus might have used one of the trade winds, which are winds between the equator and the 30-degree latitude. These are warm winds that are steady in their direction and speed. They were called trade winds because explorers and merchants like Columbus wanted to use them in order to travel. So let's talk about the ThreeSelf model. Some of the weaknesses of the ThreeSelf model is that it's just a model. In the mid-latitudes, between 30 degrees and 60 degrees, both in the north and the south, the air pressure is going to depend on the location, and it's not going to just be the same all around. However, the ThreeSelf model is accurate outside the mid-latitudes, and even in the mid-latitudes will give us an overall average, which we can look at over time. The ThreeSelf model assumes that the surface of the Earth is the same. Yet we know that continents are going to heat and cool faster than the water around it, which creates different pressure. Because the air pressure changes seasonally, the direction of the wind is also going to change seasonally. In the summer, the land is going to heat faster than the water, creating low pressure over the land and higher pressure over the water. These high pressure winds are going to go onto the land because we know whenever there's a lot of air pressure, the air wants to spread out in an area of low pressure. In the winter, the land is going to cool faster than the water, creating higher pressure over the land. This wind that changes direction seasonally is called a monsoon. And in areas like India, where moist warm air reaches the land, we have very, very heavy rainfalls. A local wind is a wind that extends over an area that's under 100 kilometers, very small. We're going to discuss an example of a local wind called sea breeze circulation. Sea breeze circulation is that during the day, the land is warmer and lower pressure. This causes the wind from the sea, which is higher pressure, to come in. The warm air then rises and will flow out over the sea again, where it cools and will come back on land. At night, the opposite is true. The air over the land will become cooler than the water, becoming higher pressure and moving onto the water. Then it's going to warm up over the water, rise up, and then flow back over the land. That's all you need to know for today. Next, we'll discuss how air pressure affects our weather. Please make sure to fill out the form and the questions below. Hit that submit button. Thanks so much for watching. I'll see you tomorrow.